Am I audible, sir?
Yes, yes, you're audible.
You are in the
I
session?
can hear you. Yeah,
Okay. Can we start now?
can you hear me? Yeah, I can start. Like maybe I
Yes, sir.
can. Okay, I'll share the screen and then I'll start.
Uh, wait, sir. It is my great pleasure to introduce our esteemed speaker for today's session, Dr. Ranjeet Ranjan Jha. Dr. Jha is currently serving as an assistant professor in the mathematics department at the prestigious Indian Institute of Technology, Patna. His academic and professional journey is both inspiring and impactful. Dr. Jha earned his Ph.D. in computer science and engineering from the Indian Institute of Technology, Mandi in October 2022. His doctoral research focused on medical image analysis, employing cutting-edge deep learning methodologies, a field that is transforming healthcare and diagnostic techniques globally. Prior to joining IIT Patna, Dr. Jha gained valuable industry experience as a data scientist at Sahaj AI Software Private Limited in Bangalore, where he worked on innovative AI solutions. In addition to his PhD, Dr. Jha holds a master degree in computer science and engineering from the National Institute of Technology, Goa. His research interests span across medical imaging, deep learning, biometrics, computer vision, and other closely related areas, making him an expert in the field that are shaping the future of technology and medicine. Today, we are fortunate to have him share his deep insight into the world of deep learning applications in medical imaging. We are confident that his expertise and experience will bring uh, tremendous value to all of us. Please join me in welcoming Dr. Ranjeet Ranjan Jha to this session. Over to you, sir.
Yes. So thank you, sir, for such a nice introduction. So let me start. So let me share the screen and then I'll start. So I assume that my screen is visible to everyone.
Yes, sir. Visible, sir.
Okay, great. So let's begin. So here, like you can see the title name, that is deep learning. So like why we are studying this deep learning? Because nowadays it's very difficult to survive without deep learning. So if you want to survive anywhere, like in academia or maybe in industry, deep learning is the tool that will help you to survive. And that's why you people are here to to learn to to see like how what is this world and how this world is evolving. Okay, so with that, so let's start. uh, so I'll go back maybe maybe 40 50 years back. So actually this deep learning is now again we see like deep learning is new, but deep learning is like it's not totally new. It was already there in past also. So how it evolved, that we'll see here. So the evolving point was artificial intelligence. So like at the starting when computer came into the picture, like maybe early 60s or maybe 50s at that time. So like we were using computer system for solving multiple problems, like whatever problems like we want to solve. Like suppose you are sorting the numbers, or maybe you are searching some number. So for that, what we do, we generally write the algorithm, we write the like code, and then your computer will do the particular task. Okay, so you know that your language and computer language is different, so that's why we have programming language. So programming language is something which can be understandable by your computer system. So you have like computer system is having compiler, and it will compile, and then it will at the end it has to convert it into binary so that your computer can understand, because your computer can only understand binary, 0 and 1. But for that, this whole game is there. So first you will write the code, and then everything will be converted into the binary. So in the past, like when this era started, then what people used to do, they just they write the algorithm, and then your computer, they like your compiler, you use compiler, and a compiler convert into the binary, and then like the task that you want to do, that is being achieved. But in that, there was no intelligence of computer system. It was the intelligence of us, because we were making the algorithm, we were designing the algorithm, so we were thinking and then making the algorithm. So that was the era when the computer started. But later, like people started to think like how we make the computer which can work smartly or which can think itself. And then this artificial intelligence started. So artificial intelligence means we are going to make the computer system so intelligent so that it can take the decision. So instead of like writing all the things, writing each and every line to give the instruction to the computer, your computer would think those things by itself only. And that is the goal of this. So we are going to make the computer system so intelligent so that it will do many things smartly. And that area is called artificial intelligence. So we are making computer system intelligent. Okay. So this is the area, and again, this came very early. It's like 1960s, 60s, 70s. That time only this idea came. Many researchers started to work in this area. Now let's see what are the different things that came into the picture in this artificial intelligence. So if you just see in the artificial intelligence, there are multiple things. I've just put two things here. One is computer vision, and another one is machine learning. Now, when I say computer vision, vision is something by which you see something, like you realize something, like what are the things going on around you. So you have like, just if you relate with human, then we have eyes, and we take the image of different object, whatever object you have around you, and then your mind is there to decide something by seeing those images. Okay. Now the goal of the computer vision is same. It it tries to mimic the human vision. So whatever vision we have, like vision means it's not only eyes along with the brain. So that is our vision system. So the goal of this computer vision is to mimic the human vision system. So for that, computer vision is having cameras, different cameras, like you can say sensors. And it takes the image from different cameras or different sensors, and then it is having a lot of algorithms which will take the decision. For example, suppose you are doing the classification between two classes like dog and cat, then your camera will take the image of dogs and cats, and then you will use algorithm. Like there are multiple algorithms in this computer vision domain, so you will use those algorithms, and it will give you like what is the class of that image. Okay, so this is again very big area. Now when one another area came into the picture, that was again part of the artificial intelligence, and that was the machine learning. Machine learning was like again it is having a lot of smart algorithms which can decide by itself, which can take the decision. Okay, but here you have to train, you have to like your machine will learn, just like us. When we started, like from the childhood, we learn so many things around us. Like whatever we see around us, we learn those things. We make mistakes. We make mistakes several times. Similar to that, this machine learning will also do same. So it will learn, it will try to learn from the experience, or we can say the information that I have, or in technical word we say data. So whatever data we have, your machine learning will learn from that, and then it will make mistake, and then it will also try to correct itself. So there are so many things, so many algorithms involved here. So I'm not going into that because this session is about giving the motivation and like what are the different applications where we can work. So this machine learning was again very interesting area which gives a lot of algorithms. Those algorithms are very smart. So in past, what people have done, they have used few, or maybe we can say many algorithms from this machine learning for solving computer vision problem. Okay, so that's why there is overlap here. Okay, now let's come to the deep learning because our topic is deep learning. I don't know, like maybe you might be knowing about deep learning, but again, I'll maybe for some of you, maybe it will be boring, but yeah, for the completeness, I have to like uh, even explain about like what is this deep learning and like that. So this deep learning is again, this deep learning is not new. It is part of your machine learning. So now you can see the big picture. So you have artificial intelligence, then you have machine learning, and then inside machine learning you have deep learning. And now whatever left here, those are called traditional machine learning. So we have in machine learning, you have a lot of algorithms. Those are like, those came very early. And those algorithms are called traditional machine learning algorithms. And now we have deep learning inside this. Now I'll just make the like difference. What is the difference between machine learning and deep learning and why this deep learning is required? So if you just recall the, like maybe some of you might be knowing about this machine learning. Machine learning is two-step process. So whenever you want to solve problem, actually whatever we are doing, our goal is to solve some problem, solve some real world problem. Okay. So machine learning, how this works, you will be having two steps, one and two. Now this is the first step. And first step will give you something, some output. And then we have second step. And second step will give you some output. Maybe I'll give you some real life example. Suppose I have to take some, maybe I have to take some students uh, for my research work. Let us take the BTech project. So like BTech student. So suppose many students are applying. Okay. So what I'll do, I'll just put some criteria. Like not criteria, but I'll ask multiple things from the students. Like what is the grade, how much grade you got till this the particular semester, and then maybe some other information also. And this information will be taken at this point. So if one student comes here, he'll be having a lot of information, maybe infinite amount of information, because he's having inside him, he's having a lot of information, his grade, his 10th marks, 12 marks, everything is there. But this first step is, it will not take all the information, because all the informations are not required, because I want that student for my project work. So like his hair color, or maybe some other irrelevant which are not relevant, those informations are not required for this particular problem statement. So it will ask only those information which are required for taking that student for my research team. So this is the first step. And maybe here I'll put my PhD student. So here my PhD student is there. And he'll ask all the questions maybe, and he'll get the response, each response here. And then he will just give these all response to me. And I am not interacting with this student. This guy is totally different. He is PhD student, but I'm not interacting with him. Whatever he gives me, I'll take it, and then I'll decide like what I have to do for this. Okay, so this is like two-step things. One is here, one guy is here, one guy is here. One is taking the relevant information from the input, and another one is taking the decision. So if I just say this thing in a technical words, so the first step is called, this is like feature extraction. So whatever, suppose you are giving one image. Now in the image we have infinite amount of information. A lot of informations are there, color information, many informations are there, but all the informations are not required. So what this first step will do, it will just take the required or relevant information, and it will give to the second step. And second step will, the second guy will do the, suppose it will do the classification. So maybe you are giving the image of cat. So from the cat, it will take the features, relevant information, and then it will give to this. And the job of this guy is to say like the class of this is cat. Just labeling, it's doing the labeling. So this is the two-step process. Now problem was in this, the problem was that these two guys were not these two guys were not interacting, and that was the problem. Because if this makes some mistake, it will affect this overall result. Because maybe if suppose this person is not good, so he can give even irrelevant information also, and in that case, this guy will be confused. So this was the issue. So then then deep learning came into the picture, and deep learning said, no, I'll not go with this. I'll not go with two-step things. Now I'll combine both the things in single box. So I'll be having one box only. So your feature extraction, your classification, like decision making, everything will be done in a single box. And there is interaction between everyone. So we'll go back and we'll correct everyone. In this case, that was not possible. You can correct separately this both guy, but they cannot communicate, and that was the issue. In this, they can communicate, and due to this, since this is fully automated, so just give the image, get the label. Maybe you can give the cat image and get the label, like it will give you cat. And this, many times people say this as a black box, but this is not black box. Okay, inside this, a lot of layers or a lot of things are there. And even this is also one research area where people work. Okay, so this is, now I just talked about this difference. So let's dive into deep learning because that is the goal. Okay, so with that, let us take one simple example, very simple example. This is a simple example. You have given this image, and goal is to say what is the label of this image, like what is inside this image. So you can say cat. So for us, this is very, very simple problem. Why? Because we have been trained in this way. So our brain knows that what is this. So we are very good in visual, like understanding the visual image, because our training has been done in that way only from childhood. Okay. So you can easily say, oh, no, no, this is cat. But then how to interpret, how to give this thing to the computer system? Because your computer system does not know. It cannot understand this visual picture, because you know that your computer can only understand binary, either 0 or 1, or maybe numerical value. Maybe I'll just say numerical values. So your computer can only understand numerical values, because numerical values can be converted into binary. Now, for us, this is very simple problem, but for computer, it's not very simple problem. The first thing is like how to give this to the computer system, because it cannot be given in this as it is or directly, because this is visual thing, and visual thing is by your computer system. So then what we do, like in computer vision, maybe many of you might be aware of this. We like convert this thing into RGB image. Like it's like one type of uh, uh, what we can say, like the conversion of this visual into numerical values. Okay. Again, this is, you can understand, this is like part of image processing. So it's very easy thing. So your image would be converted into values, pixel values. Then these these values, by seeing only these values, it is very difficult to decide what is the level of this. Now, if I show you these values, like suppose I have converted this into values, this maybe 255, 56, like that. All the values are there. The range is 0 to 255. This is the range of that, and we're having RGB like red, green, and blue channel. Now, if I just show you this, you cannot interpret. You cannot say. You will be not able to tell what is this. Now, for us, it is very difficult. You can like you can relate this thing with computer system. How difficult it would be for the computer system. Okay, but again, since you know that your computer system can understand the binary thing or numerical thing, then maybe you will do something so that your computer system can understand this. So what we do, we give this thing to the computer system, and we somehow train this. We somehow train something, some algorithm, or we somehow learn some algorithm which can understand this. So for this again, you will be using computer vision, because computer, whenever there is image or there is video, you have to use computer vision. Vision is like involved whenever there is image or video. So we have algorithms, and by applying algorithms, you will be able to get the class level. So you'll give this, and your computer vision algorithm will tell you this is cat. We'll see like how your computer vision will do this thing. So how it does this thing? Your computer vision will be trying to learn classifier. Classifier is something which can classify between different classes. So suppose if you have dog or cat and cat, these are like two classes. We have a lot of image of dog or a lot of image of cat. So now your classifier, you are going to learn something which will help you discriminate between dog and cat, like which can tell you whether what is this. Like whenever you are giving some image, you should be having something which can tell you like what is the level of this. So your classifier is that guy who will help you to tell you what is the class of the particular image. And let us begin with the very simple classifier that is called linear classifier. So this is the linear classifier. So it is having one linear boundary. And whatever dog images we have, all images will be going this side. And whatever cat images we have, all the cat images will go this side. Actually, I'm showing you this in a 2D space, but actually this will be in a multi-dimensional space, because in image you will be having a lot of pixels. So you know that if you have only two values, then you can show in a 2D space. But if you have like n number of values, then you can show in a multi-dimensional space. Okay. But in 2D, you will be having this simple line which can differentiate between two different classes. Maybe you can take this example as a India-Pakistan border. So, like goal is to put all the Pakistanis people on this side and all the Indian people on this side. That is the goal. Okay. And whenever someone is coming, some new person is coming, now this boundary will decide this person should go which side. Okay. So based on, like, you have to fit this. So whatever suppose new sample is coming, so we'll just ask with this boundary which side I should put this sample, and then your boundary will tell you. Okay. So this is very linear classifier, but in general this does not work, because in reality you will be having very complex problem. And whenever we have very complex problem or very non-linear problem, you cannot solve using linear classifier. But this is very basic classifier from where this computer vision started. And now, like whenever new image is coming, it will just fit here, and you will see like which side this image should go. So suppose your new image you are giving here, and then it is by fitting this, it's coming this side, then it will say no, this image is of cat. Maybe I can take technical word cat and dog. Then it will say no, this new image that you are giving to me, that belongs to cat. So in this way, like this is doing the classification task or labeling task. Okay, so like even in computer vision, there are a lot of algorithms which do this. Like, let me before going to that, whatever algorithms we have, like linear classifier or anything, which are going to solve some problem, solve some real world problem. For that, you'll be having these two terms. So I'll not go into detail, because I generally take one semester for teaching this whole, like whatever I'm going to discuss here, I'll take one semester to teach this whole we can say chapters. So again, this is one chapter. Maybe you can say like these are two chapters: regularization and optimization. These are two chapters. Actually, the goal of this optimization is to train your model. So whatever linear classifier or whatever model you are going to train, because at the starting it will do a lot of mistakes, just like child. So at the starting, your child will make a lot of mistakes, but you will correct it. You will correct him or you will correct her. So this optimizer he's the guy who will help the model to correct itself, so that next time it will not make that mistake. So every time your model means like you can say like linear classifier as a one model, because it is classifying, it is discriminating two classes. Okay, so your model could be anything, like what, like based on the goal you'll be having model. And we also say architecture, sometimes we also say network, but model is something which will do something, which will solve some problem, some real world problem. Okay. So, so every model will be optimized. Like every time it will be, it like your model will correct itself using this optimizer. So this is the guy which will help this whole process happens in a proper manner. And again, regularization is also one topic. I'll not go into that because this is not the goal of this session. So these are like two things of deep learning. Even these are also in machine learning. So you have to use this for your model training. Okay. Now, Uh, let us uh, understand. Let us begin with the deep learning because we already have started the deep learning, but we haven't come to the architecture part or the network part. I've just shown you the very simple linear classifier, like between two classes. Now let's start the deep learning era and let's see how deep learning evolved and what are the architecture, what are the new models came into the picture. So if you just see the deep learning, it started with neural network. That was the basic architecture. That was the first architecture. And sorry. So this was the first architecture in deep learning. So how it works, I'll just explain. So again, this is called neural networks because it's inspired by your brain, our brain. So neural is like our brain is having a lot of neurons, and all the neurons are connected. And whenever we are doing some activity, neurons are activated, and they are exchanging information, and then you are sensing that. Okay, so everything you know that your body, full body, is being controlled by your brain, and whatever activity you are doing, that is being controlled by your brain. And in brain, like it is like a lot of neurons are there, and they are connected, and they are exchanging the information. So this neural network has been also built in a similar fashion. So you can see like here we have multiple layers, a lot of neurons. These are like neurons. This is neuron. This is neuron. These are neurons. A lot of neurons are there. This first, if you just see the first, like the first three, these are called input neurons. So input neurons is like the input that you are going to give to the this neural network. So in our case, suppose you are going to design a classifier or labeling, like in very vague way, I can say like labeling. Okay. So suppose you have to label this image. So you have to train the architecture. You have to train the neural network because it's not like magic. Nothing is magic. Okay. Whatever you are seeing here, everything is being trained. Like you have trained your model. That's why it's doing job. So at the starting, what you do, will take this image, and now this neural network it will not take this full image as it is. What it says that you first convert your image. So you have like this image is not in this way, you have this numerical values, a lot of numerical values are there. So what is being asked here, it will ask you that first you convert into vector. I'll take vector. So whatever information you have, you convert into vector. And in this vector, every value, this is called input because you are going to give this thing to the neural network. Now this vector, every value will be called one neuron. So whatever value, suppose you converted this and you got three values only. Maybe I should have other values. Maybe I just take three values only. So you converted your image. Suppose this is a hypothetical image. Okay. In general, you will be having a lot of values, but suppose just take the example of hypothetical image. So you have only three values. Now this first value is first, you will give this value to here, this value to here, this value. Now these are called input neurons. Now you have in between hidden neurons. From three values, you are just interacting with four other neurons. And then from these four other neurons, you are interacting with four other neurons. So these are called hidden layers. And at the end, you are going to the only single neuron. Because at the end, you have to take the final decision whether this is cat or dog. So it will give only one value. So maybe it will give you probability value. So like in this case, it will say you, I am confident that this is cat. So I'm giving 0.9 probability for this. So whatever input you have given by like interacting with these all these neurons. At the end, I reached to this point that the probability of this, the probability of this input, oh no, sorry, the this image is having like this image belongs to cat with probability 0.9. It's giving a very high probability. So when you match this, so your model is giving this. Now you have to match with the actual, like what was the actual. So we'll go and we'll see like what was the actual, and this was like manual. You have made this value, you have made this label. So it will match with this. So this case it is matched because whatever your model is giving, you have also the same label for the given image. But this is like we can say happiest case. At the starting, you will be not getting this case. At the starting, your this everyone will interact and it will give you a very wrong result. For example, it will give you only 0.1 probability for the cat. So it's saying, no, no, this is not cat. But in actuality, this is cat. So now you have to correct it. So first you have to find like how much error you have. So for that you have loss function. So I'll not go into that, but like that loss function is again one area. So it will find the loss, how much loss is there or how much error is there. And then it will go back. And here it will use the optimizer. It will go back and then it will correct each neuron so that next time it will not make that mistake. So this is learning. So every here, whatever you are looking here there is matrix. It's like matrix multiplication. So again, I'll not go into that. So this every value here, multiple values are involved. A lot of values are involved, and all those values will be updated. So initially, it will take all the random values because it does not know what I have to take, what values I have to take, so that at the end it will give the right decision. So it will take any random. That's just you. Most of the time, you just give the random values, and then when it gets loss, it gets error, then it will correct itself. It will change the value so that this value would be changed or your error would be reduced. So that is the ultimate goal of this, and in this way this learning is happened. So every time it will go, it will take the image, it will find the error, and then again it will correct itself. And these are the values, these are the weights, all the weights are involved. So this was the first neural network which came at the starting, and this is also called fully connected network. Okay, so let's go for sec. So okay, so I'll already have talked about this. So whenever like why we are doing this, where we are doing, where we are, why we are applying this deep learning, because you have to do some task. If you do not have any task, then you will not use anything, you will not go for any tool. So we have task. So that's why you are like you are going to use, like you are studying this whole deep learning thing. And for these tasks in deep learning, you will be making the model. Model is like you just started with neural network. That is the first model. And you will be making a lot of models which can solve these tasks. Okay. So, sorry. Yes. So where I was? Yeah. So I just talked about the fully connected layer, fully connected neural network. Now that was for the classification task. Like you are just labeling labeling the image. There are there are a lot of other type of problems which exist in the world. So every time it's not like you are solving only classification problem. You could be having a lot of different type of problems. Classification is one of them. So let's see here. What are the different problems that can be solved using these deep learning approaches? One is classification, very easy. Give See the image. give the label, which is cat. The next problem is slightly harder problem, which is called semantic segmentation. Now I'm not only interested in this object. Now I'm interested in multiple objects given in the image. So if you just see this image, there are like you can divide this whole image into four different categories. This is one, which is your sky part, the blue color. Then we have tree part, and then we have again cat, and then we have grass part. So now this is again called semantic segmentation. So here it will give you four different classes along with this color. So this is some sort of clustering. So one type of objects will be clustered in one class, and another type of objects will be clustered in another class. So this is more harder than this because here you had to give only one class. Now here you have to give four different classes along with the color coding, like where that class is. Now let's go for some other problem. Sorry, that is called object detection problem. This is highly popular. It's very, very popular problem. Now in this problem, what we do here, like we have to detect the object. So inside the image, there could be multiple objects, and our focus is to detect that object. Let's take this example. In this whole image, our focus is detect dog and cat. These are like two objects. Okay. So this object detection is like it's give you the location of the object, where that object is. You can see like this is giving you the box around that object, along with the class also. So saying that the class of this is dog. For this again, this is also saying that this is the box and the class of this is dog. For this is saying this is cat, this is the location of the cat and the class of this. Now this is very, very useful. Uh, we can say the this what we say. This is very, very useful uh, problem in real world. I'll give you one example. You know that this self-driving car. So self-driving car is like driverless car. So it's like there's no driver there. It's deciding, it's doing everything by itself, and it's running on the road. Now running on the road, like it has to decide, like whenever, like it is having a lot of like sensor, but it has to decide like when I have to stop or when I have to just continue, when just have to proceed. So suppose some pedestrian is coming on the road, maybe some person is coming on the road. So in that case, your car has to stop. It has to put the brake, otherwise it will hit the person. So that is not allowed case because if your car is hitting the person, then this is not. Then you have that car is not acceptable. Or maybe just take some other scenario when there is some stone, small stone on the road. In that case, your car should not be stopped because it's very simple thing. It's just it will not damage the car, and there's no problem. You can just can run. It can go ahead. Now, how to decide these things? Saying this thing is like looking very easy, but then because this car is doing everything by itself, there is no human there, there is no driver there. So even in that case, this car use this concept. So your car is having sensors, a lot of cameras, and it will take the image of roads, the surrounding, all the surrounding images, and then it is having a lot of smart algorithms like this object detection algorithms, and these algorithms will tell the car that the first thing like how far that object is. So again, you have to find the location. You have to find the location along with the distance, how far it is. So there are multiple things involved, but this object detection is very, very required thing there. It has to detect the object, where the object is, And then it also has to say like what is the class of the object, because that class is also the crucial part. So if the class is person or pedestrian, then there is problem case, because then car has to put the brake, otherwise it will hit the person. But suppose your object is something stone, a small stone, then in that case there is no problem, it can continue. So that's why this object detection is very very crucial in that case, because it's giving you the location along with the class. So this is just I've just given you one example. There are a lot of examples. There are a lot of problems where this object detection will help you. Now, next thing is instance segmentation. Now, it's like we can say the more correct version of this object detection. So in the object detection, you can see like we are just getting the rough boundary. So it's not exact location, but it's like rough location. But in the case of instance segmentation, I want exact boundary. So it's giving you this contour shape. You can see like just touching the object and giving you the shape. Okay. And again, it will also give you the class, but exact location. Now let's see what is the use case of this. So again, in this case, maybe I'll give you one example. Like this is very very useful in medical domain. So suppose a doctor has to do surgery in the brain, and like he has to just take out the tumor from the brain. Now in this case, in that case, since your tumor can be anywhere, maybe suppose this is in the very inner part of the brain, like reaching there is very very difficult work, because when you try to reach there you will be disturbing some other tissues, and if you are disturbing some other tissues, you know that your brain, every part is very very crucial, every part is controlling maybe some part of your body. So if you disturb some part, then maybe your control over that body part will be gone, that you don't want. So in that case, like what doctor does, they generally take like this instance segmentation will help you in that case, because it will give you the exact location, exact position. So maybe in that case you can go precisely there, and you can just take out the like he will take out he or she will take out the tumor from that particular location, and then that surgery will done. So again, this is very, very useful in medical domain, because it gives you precise location along with class also. So you also want like what is the class of that tumor? Maybe it is malignant or maybe it's normal tumor, because you will be treat accordingly. Okay, like your doctor will treat accordingly. I'll give you one more example. So one person, he was very good in this. He was playing very good in guitar, like playing guitar. So he was like very popular in that area. Maybe even in USA or somewhere. Like I just forget the name of the country, but like maybe in USA. So like he had a tumor, like he got to know that he had tumor in the brain, and that tumor is like that tumor was like in some maybe in white matter area. So that is very danger area. So then doctor said that we'll take out the tumor from there, but it will hurt some of the tissues. So we don't know like what are the parts that will be losing control from the brain. So because if I go there, like any path you are following, it will disturb or it will hurt some of the tissues. So we have to find the best path so that it will disturb only some tissues. But even in any case, it will hurt the tissues. And if it is hurting the tissues or neurons, then definitely some of the body part will be losing the control from the brain. So then that patient says no. Patient said no. So I want my this art, whatever art I have, like this playing guitar, this should be there. If I lose this, suppose if after the surgery, if I'm not able to play the guitar, then I'll not survive. Then it will be difficult for me like to survive here. So then doctor said, okay, if you want to like keep this like even after surgery, then what we can do? What they have done, they have just when they were doing the surgery, that person was playing the guitar. Okay, and so that like when they see like something is happening while playing the guitar, they will stop there. Okay, so that art should not be missed, or that part, that the control from the brain to that particular art of that particular person should not be go. Okay, so somehow they have preserved that, they have managed to preserve that, and even after surgery, the person, yeah, the person has got some like that person had lost some of the control, like the body control from the brain, but that part was already there. So he, even after surgery, he was able to play the guitar. So in that way, like doctor do this whole surgery, and actually this whole thing, whatever we are studying, like this instance segmentation, this helps, like how to go precisely so that we can that it will disturb only or it will hurt only some of the parts of the tissues. Okay, so I took a lot of time here. Uh, okay, so I've talked about these three, four problems. Let's go move ahead. So till now I've just talked about image-based problem. So whenever you have image, yeah, photo. Whenever we have normal in normal ways, so say photo or image. So whenever there is image, you know that you like whatever we have discussed, those algorithms can be applied. Now, what about video? Because nowadays, this is the era of videos. Every time, whenever you just open your Facebook, open your Instagram, or maybe anything, you'll just see a lot of reels there, a lot of videos there. So now people are like, it's not only interested in image, they are like interested in videos as well. So if you have videos, then how to deal with videos? So for videos also, multiple algorithms have been developed in the deep learning, and multiple they have tried to solve they have tried to solve problems with uh, different approaches of deep learning. So like this. So suppose you have uh, video means you have a set of frames, a lot of you will be having a set of frames like you see a lot of images you will be having. So for this again, for this type of work, a separate like there is separate techniques which can be applied on this, and you can do multiple tasks. For example, you can see in the first image, this is video. I am not able to show you here video. It's looking like just image, but it's like a lot of frames are there. The person is doing something. So maybe in this case, like this person is maybe if you give this video, your model will say like this person is running because that person because it is clip, it is video clip. Okay, it's not one image only. Okay, so I'm not able to show you, but this is video. Okay, so it will that model will say and see, and it will give you like this person is running or maybe walking or jumping. Okay, so this is like this is again classification problem, but it's not like image based classification. It's video based. So it's taking the video instead of image. So again, it's more challenging problem. Then in the second case, if you just see, this is even more challenging problem compared to this one. In this here, multiple modalities are involved. So in the first case, only images were there, like just sequence of frames this person was doing. In this, the person is doing something, is playing something, along with sound is also coming. So we have two things. One is images, a lot of images, a lot of frames are there, and you have also sound. So it's like called multimodal. And your model has to understand like what is happening here. So maybe model will say like this person is doing something, it's playing something. or maybe what he's playing, that can be also said by the model. Okay. So again, this is a very, very interesting problem. Then the next is again, this is also I'll say like initially people used to say like whatever model, whatever I'm talking here, that is like what that is black box only. So because we don't know what is there. So why we don't know? Because actually, if you just see that black box is containing a lot of mathematics, but those mathematics concepts are very, very difficult, and it's beyond our understanding, and that's why we are not able to understand. So we have made the system, we have made mathematics it's very complex, and that complexity is even not digestible by us. So initially, like the this discussion was that no, this is just black box, and people did not. So like this black box, you don't know what is happening. But later, like again, research has started in this area also. They People started to understand like what is happening there, and again, so this is again one area where people do research, and it's called visualization and understanding. So it's like try to understand like what is happening here. So from in model you will be having multiple layers, what I talked at the starting, and it people just try to understand like what is happening. So when like in the one model they have given this, and then what they observed that at this area they were getting the white patch, and you can easily say that since our focus goal is to give the class of this image, and the class of this image is dog, because the class in this image is the foreground part, or the main part is this only, and that's why your model is giving focus on this part only. So in this way, like they have just given the uh, intuition, or maybe the justification, like how your model is trying to understand different things from the image. Okay, so like I'll talk started with the neural network, and that is also called multi-layer perceptron, and this is also called fully connected. So that was the first layer. Then people also started to like fully connected, or this multi-layer perceptron was good. It was good, but the problem was like problem with this model was that it was seeing the image from the top, because you were just giving the full image. It's just like you're there on the moon and you are watching the earth. So what you will see, like if you're on the moon, you will just see the top view of the earth. So that is your fully connected, or that is your neural network, starting neural network. So in that way, what will happen? Like you will be missing some of the nuances, like what is inside the earth, because in the earth you will be it is having a lot of things. But since you are looking from very far, that's why you are not able to visualize. You are not able to see each and every part of that. So that was like you're fully connected. Then people realized that, and then again researchers came up with the idea, like instead of seeing this full, I should also see part of the image. Like just go to the earth, just go to close to the earth. Instead of seeing from the moon, just go to the close to the earth, and just see the image, see the earth, like what are the different things in the earth. So that is your convolutional neural network, CNN. So CNN is like you will be having filter, small filter, and it will just see the small part of the image, or small part of the input. And once you're done with that, once you just see the let's see, take the example of earth. So if you see the earth from we can say from the close distance, then once you have like that information, then maybe at the end you can go to the moon, because now you have collected all the information. Now you can go to the moon and just see the whatever information we have, just take those all the information, and then take the decision. So like once this CNN came, then generally like doing for the classification, this type of structure came into the picture. So what people used to use at the starting, they used to use CNN, because you have to go to the close, and see the input. And once you are done, then at the end you just apply the fully connected. So that this is like combination of both. And at the end you do the classification, like just what is the class of that. It's like final decision that you are making. Okay, then one whatever I have talked, that is all about computer vision domain. So whenever we have images and videos. Now there is one more emerging areas, and that is NLP, natural language processing. So maybe some of you might be working in that area. So like it started with this CNN and fully connected, but then how should do deal with the text, the NLP, like natural language, because in daily life many times you'll be using text. Now, what are the different tasks that can be done on the text? That is the first thing. And it's again, NLP area is taking care of that, all the things. Now, if you have that, then how to use deep learning for that? Because you want you know the power of deep learning. So you want deep learning, then how to use that deep learning for that? So again, for that, one more area came into the picture, and that area is called again that type of neural network is called a recurrent neural network. So the recurrent neural network will take care of all the textual things. So if you have, suppose you are going to use you are going to do sentiment classification. So sentiment classification means like you have given the paragraph and then you have to decide like what is the sentiment in that paragraph, whether this is positive sentiment or negative sentiment or it's like neutral. So for that, you cannot use CNN because CNN is like for image. For that, if you use fully connected, it will not work good. For that, we have RNN. And again, RNN is again one big chapter. Okay. So I generally take 3 4 lectures to complete this, even more than that. So RNN will process a full paragraph one by one. It will take the aggregated information and then it will decide like what is the class of this particular text or this particular sentence or this particular paragraph. Then RNN was the starting point, then it had several limitations. The first problem was that it was not using the GPU power. Let me just tell you, deep learning became popular due to GPU and data because these approaches were there in the past also. It's not like new approaches. Even in 1980s, 1990s, these all the like many approaches were there, many methods were there. But that time it was not popular. Why? Because we did not have good data, good data set. And also we did not have powerful GPU. GPU is like graphical processing unit. That gives you a lot of cores, multiple cores. Like if you just see your computer system, it will be having 8 cores. But if you just use GPU, it will be having 4,000 cores or even more than that. So you can process 4,000 process parallelly. Or so that is the power of that. So that's why like since this whatever algorithms we are studying here, every algorithm needs a lot of parallel computation. And for that, GPU is the only tool which can help them. Okay. So that's why like it was not popular in 90s, but when 2008 came and around that like data set, Fifili like she published ImageNet data set. That was the first data set which was having millions of images and 1,000 classes. So that was the benchmark data set. And then research started. Again, at the same time, GPU also started to grow. So we had like good GPU, good powerful GPU at that time. And that's why the main research started from 2010 or 12, around that. And then everyone is started to dive into that area. Okay. So when this recurrent neural network came, so it was good, like it was doing like it was performing well, But the issue was that it was taking a lot of time to train. So maybe if you want to train one small problem, it takes 2 days, 3 days, or maybe if you are going to solve uh, like solve one complex problem, it may take 15 days or maybe 1 month. So that was not acceptable. Even it was acceptable, but that time it was like you did not have any option, then you had to go with this. But then later people started to think in this direction, like how to again how to speed up this process. And again, it was also having some other limitation. Then they started to think in all the directions, and then researchers came up with the transformer. So this was the, we can say, like the main, or we can say what we say, the the magical point in this area. So recurrent neural network was giving everything, but then when transformer came, then everything has been changed. So transformer is very, very fast. It can use all the GPU, it can use the parallel processing, and then it can solve problem even more accurately compared to RNN. Okay, so till now recognition part. Now let's go for the recognition, means like classification, detection, and like that. Now let's go for some other task. Uh, there are even more creative tasks which can be done using your deep learning. And this is the first one, genetic models. Now you can see, like, this is the natural image that you are giving to the model, and your model is giving you the cartoon image. Now it's like, and it can give you this image maybe in a second. You can now you can appreciate this whole model or whole deep learning thing. Because even if one cartoonist he's going to draw this cartoon image, it will take a lot of time, and that the same thing is being done by your model in a second. Now it's taking the job of the cartoonist. So you can even these type of things, a lot of things are going, it's like happening, because whenever some technology came into the picture, it's having the bright side, like it's having the a lot of positive things, a lot of advantages, but at the same time it is also having some dark side. So dark side is like, if you have, like if you're just using the traditional thing, maybe you are in trouble, because you're somehow like your, maybe this AI thing will replace your job. Whatever job you are doing, maybe in a 2 days or 5 days, it maybe your AI will can do that work in a 1 day, or maybe no, not 1 day, maybe in a second, or maybe in a minute. So yes, that is the problem. But again, we have to appreciate this, because researchers have done this thing, and we have reached to this point where we can do this type of magical thing. So that in that way we should appreciate this. But yeah, yes, again there is dark side also. So if you want to, if you have to survive, then you have to go with the this AI stuff. You have to understand, like, this what this technology is and how it's working, and somehow you have to use this technology. Just see one more example of generative modeling. Now if you just see, this is again generative task. It's a very simple task. It's just like when you go to the class, like many of you like are faculty, so that's what I'm saying. When you go to class, so and when you say like just draw this image, and to the student, then every student will start to draw something on the page. Now similar type of job can be done using your deep learning model. And again, you have a lot of models, and Delhi E2 is like one of the popular models. So you'll say like, draw this. Teddy bears working on a new AI research underwater with 1980 technology. And you can see the realistic image here. It's teddy bear working on some AI research underwater. This is water, and it's like slightly old technology. So looking like a 1990 technology. So this is giving you very, very realistic image. Again, there is one area where people combine image with text, and this is called visual language model. So that is one separate. So I'll not go into this. There are even multiple other jobs. Again, the similar thing can be. Let's see a few more funny example. It's looking funny, but you can appreciate the work of this. So again, daily E2, the same model that I've discussed. You can see multiple text, maybe different sentences. So Teddy Bear working on new AI research on the moon, 1998. You can see like this is moon, your Earth is looking here. It's old technology, and Teddy Bear is working here. Again, interesting example. Rabbits attending a college seminar on human anatomy. So, like hypothetical text, hypothetical image that we want, but you can see like it's giving you that image. So rabbits are there, all the rabbits are there, and this like teacher, professor is teaching, and it's like human anatomy is there. Even a wise cat meditating in the Himalayas, searching for the enlightenment. So you can see like the similar image that you are getting here. Oh, sorry. Even few more, many more examples are there. So like text is like I'll not go there. Now you can also generate. You can instead of giving one sentence, you can give one full paragraph. It's just like a story. So whenever you just you when you like read the cartoon based story book, then what we have generally we have like the text, and you can like even if you see some person is saying something, someone is doing something, someone is saying, so in this way, like this is like cartoon based we can say cartoon based story picture. So this type of thing also you can do using the deep learning model. So it's like Delhi A3, E3. It's like the next version of Delhi E2. It's giving we are giving one just paragraph, full paragraph, and then it's a your model is giving you this picture where it's what is happening. It's saying like what is he doing, what is he is doing, and like that. Now, ChatGPT, I know that most of you are aware of that. Most of you uh, will be like already have been using that. That ChatGPT nowadays, like it's very common. So many of us are using ChatGPT for doing a lot of manual work. So ChatGPT is again based on the text. So you just give a text and you get the response from the chat GPT. So that is GPT 3.5. It's based on the GPT 3. And GPT 3 is one version of your transformer that I told you at the starting. Now there is GPT 4, and this GPT 4 is also have it has been already incorporated into chat GPT also. So GPT 4 is here also here what they have done, they have also incorporated the image. So text was there already, but what they have done, they have incorporated the image. And now you can ask, you can also give text, you can also give image, and you can ask the question from the image. So like suppose what is unusual about this image? And your GPT-4 is saying the unusual thing about this image is that a man is ironing clothes on ironing board attached to the roof of the house. Even in this also, you are giving this and you're asking. So again, this is GPT-4 where they have involved image as well as text. Then one more very interesting problem that is when I was talking about segmentation. So what I told that you can just precisely you'll do the segmentation so that like object detection, and then we have seen the segmentation. So that is like even more precise compared to the object detection. So actually, in the past, when we were needing some model for some type of problems. So, for example, you are working on some normal image segmentation, like in the image, you have to segment cat, dog, and like that. Then you will be taking a lot of images of that, and then you will be making model, and then you will be having model. Again, suppose you have your data set had been changed. Suppose you are working on some other problem, then we'll be having again you have to train one another model, and then you will be training that. So in this way, like for different type of segmentation problem, you will be training different models. Now this SAM came and it says only one model will do all type of segmentation. Whatever image you have, either medical image, normal image, even in the normal image, whatever type of images you have, I'll do segmentation from the single model. And this was like given by the Facebook Meta. So segment anything model. So you can segment anything. Just give the input and I'll give you the segmented output. Uh, this is again more interesting example. So till now we just have seen the image. Now you can also generate video. So just give text and you'll get the video. Generated video. It will give you video. It's like it's only one. You're not able to see this video, but this is video. So it's just first frame that you are seeing here. Again, this for that Sora is the tool. Sora is the again deep learning tool that can be used for the generation of the video. Even you can also edit the video. For example, this is one video, and now I want something here. So I change this. Now this is the change video. Again, suppose this is the original video, and now I've said that now put the video in the space with the rainbow red. Now your my video has been changed. Even here, change the video setting to be different than a mountain. Perhaps now this view has been changed. So whatever editing you were doing manually, now it has been like now it is happening automatically. Okay, now you can go beyond 2D. So there is 3D vision area where people work. So it's like again hot area like where we generally deal with the 3D things, 3D image. Okay, so I'll not go into that, but again, if someone is interested, that they can work in this area. Okay, so this is my last slide. So why I put here because whatever we have studied here, that was not possible because of these three people. So first one is Jeffrey Hinton, then Isu Bengio, and then Jan LeCun. They are called godfather of deep learning. They started this deep learning. So the deep learning area started with them. And for this whole deep learning thing, they got Turing Award in 2018. That is like most prestigious, like it's like we can say the Nobel Prize of Computer Science. So they got this. And even more interesting, last year, this guy, Geoffrey Hinton, he got Nobel Prize in physics. And why? Because many algorithms have been used in physics for solving several unsolved problems. And they have used the approaches or methods designed by him. And that's why this guy has got this Nobel Prize. Even surprisingly, even in the same year, in the chemistry also, like three people got the Nobel Prize. They in combined way. Two of them were from the this artificial background, and they were working like they were working in a company, maybe some like Google or maybe somewhere, and they got this Nobel Prize. Why? Because they have used the algorithms for solving a lot of unsolved problems in chemistry. So you can see like it's not only up in computer science or maybe in technical. It's like now it is everywhere. So even you are working in mathematics area or you're working in a physics, chemistry, math, every mechanical, chemical, every area, you have to somehow You have to some way you have to use this for surviving. Okay, so with that, I'll stop here. So maybe I'll go for the question answer because I do not have that thing to say. So I'll stop here. So if anyone has any question, then he or she may ask. Uh, I finished early, so I think yeah. So you could ask question if anyone has. So I did not consider this coding part because I think that coding you can do by yourself because most of you are like faculty members. So like your student will do, and even if you because coding is not the big deal nowadays. The idea is the big deal. So that's why I thought of not putting code here and just explain the theory and this evolving area so that it will help you uh, to to jump into this area or to like start it, something in this area. So anyone has any question, please ask. I'll just stop here. Uh, hmm. So let's see the yeah. So I can see some of the questions. So what is Adam optimizer? Uh, it's like actually the first optimizer was SGD, stochastic gradient descent optimizer. So optimizer is something which will help you to change the values or change the model so that next time you will be having better model. So Adam is also one of the optimizers. So it's like one variant of your stochastic gradient descent. So SGD is like first one that came start at the starting, and then like every time whatever algorithms are coming, every algorithm is having some limitations. So that's why many variants of SGD came into the picture, and Adam is one of them. So again, explaining this Adam in a single like in this short time is not possible, but you can just understand this as a one variant of uh, stochastic gradient descent optimization. Hi, thank you, sir. Thank you. Sir, is ensemble two different model to improve accuracy novelty is uh, sir, ensemble two different models to improve accuracy is novelty in the research. Uh, yes, it can be, but like this was in the past, people were used to do this, and they were like combining different like two deep learning models in a single like combining two deep learning models and then getting some improved results. You can do this, but again if you are taking both model as it is and they're showing and just your performance is getting improved maybe by 1% and 0.5% like that, then it's very difficult to publish that paper at top venue. But you can publish somewhere. But publishing paper on top venue, even you have to put some novelty in the part also, like in every model, like whatever model you are proposing. The next question is, can we do something in anomaly detection through it? Yes, it can be done. Anomaly detection is again one area where people use this thing. Even I also work in this area. So it's like industry-based problem. So anomaly detection can be done, and you can find multiple papers. It's like even very hot area, and where people use deep learning to detect defect in the industrial product, like how to detect. Because in reality, like in general, you'll be having only lesser amount of defect image. So it cannot be solved as a simple classification problem, because whenever you are going to solve something as a classification problem, then you would be having a lot of samples for all of the classes, whatever classes you are going to take. But in this case, like when you are dealing with anomaly detection, anomaly is like you don't know like what type of things, what type of defect can come into the future. So this is again very interesting problem, and this cannot be solved using a simple classification problem. So people do something. They like solve this as a one class classification problem, or maybe some clustering based problem. So there are multiple techniques you can find out. Even I have also one paper I have seen. So, but very interesting area. Any other question? Yeah. Can you we use in medical field? Yes, definitely you could use. In medical field also anomaly detection can be done. So whatever new, like whatever uh, things are coming in the body and you are not able to understand that, that can be considered as an anomaly. So even many problems can be boils can be boiled down to the this anomaly detection problem. So in a starting, maybe at the starting will be having different problem, but you can boil down that problem to the anomaly detection problem. So this is very interesting area, and people use this in medical field. But it is very popular in an industrial field, because they're like we directly see the the effect of this. Even in the medical domain, also people do this anomaly detection. What will be future of deep learning? Future, uh, yeah. So future is unpredictable. So it's it's going very fast. So now you can see like every day, even in a month or maybe in a 6 month, technology is getting changed. So future is not only deep learning, because uh, like it's one type of technology, but they like other technology would also come in the future. So maybe one technology could be quantum technology. That is also like one type of. Again, people will be using deep learning there also. So, and like some other maybe RL based technology, reinforcement learning, and like that. Those things are also not. It's not that it will come into future. It's already people are already working that area. But again, this is not very popular nowadays because of limited resource and other things. But again, after maybe 5 years or maybe some years, those things also will also come into the picture in a proper manner, and then deep learning is already there. So again, this is evolving area, so every day it's changing. So we don't know what will happen, but like somehow it's this technology is trying to uh, replace or trying to solve the manual work that we do. So most of the manual work is getting are getting automated. So now these machines, this deep learning based technology are getting incorporated in multiple machines. And now instead of humans intervention, now your machines are itself doing the work. So that is the great thing. So maybe deep learning can, we can say, like in future it, we should not say, but in most of the tasks it may replace humans also. So that's why ethical issue is there. It's like again in one another area. Uh, it's just like atom bomb. So at the starting, everyone like was trying to make the atom bomb, but once they just made the atom bomb, then now you know like what are the, like what is the danger side of that. So similar to that, AI is also evolving. So yes, people are also now they are also focusing on this ethical issue, that part. And somehow like we have to manage. It should not go, like everything should not go in the hand of robot, because we are making the robot smarter, like it's getting smarter by day by the days. So like maybe if we give all the power to the, like your like robot or maybe machine, then it will be very danger for the humans to survive. So I think this area is very, very critical areas where people are thinking, and they are trying to somehow manage, so that at least there will be not having some, will be not having like this type of danger in the future. Any other question? I thought of like completing early so that you guys can ask some questions, because this is again interesting area. So that's why. That you use deep learning. If yes, then to what? Yes, ChatGPT is fully based on deep learning. ChatGPT is using, GPT is like your one variant of transformer. And transformer, that I said you, like it's like after RNN, transformer came into the picture. And transformer is like one method or one technique of your deep learning. So it's using fully this deep learning. And it is having, apart from transformer, it is also having reinforcement learning, RL, which can also think, like it's just like learning from the mistake. So your RL is just like it learns in the similar way how your child learns. Okay, so that's why like it's fully trying to mimic the humans. So even it's having more, it's more powerful than this transformer, because it's like transformer plus RL. So every time, like whenever you will give some text, so it will give you some sentence, some responses. And suppose you are not happy with that, then like you are also giving feedback. No, I'm not happy with this result, and that feedback is getting back to the model, and then model will learn that this guy does not want this, or whatever information I'm giving, that is not more relevant. So then it will change itself, and then it will give you. So it's like every time your model is also learning from the surrounding, like from us. So that smartness is there in that model. Because in general, what we do, we make the model and we just deploy the model on the server. And now we are not going to train. Just use that. But chat GPT is something, or like whatever this type of, I'm not talking about only chat GPT, because there are a lot of models. So chat GPT, like this type of model, how what they are doing, they are also every time they are making themselves correct based on the surrounding. So it's every time it's changing its values or changing its model, and that is the greatness of this. Uh, Pre-processing, why do we need to do pre-processing? We do generally when your data is not good. So, like maybe I'll give you one example. Suppose you have, suppose you are giving image, uh, to the model, suppose deep learning model, and your image is blur or it's like having a lot of noise. So if you train your model, because whatever you are going to show to the model, your model will learn that. Okay, so it's not like totally magic box. It's just seeing the surrounding and then it's learning. So if you are giving noisy input to the model, then your model will learn incorrectly. Okay, because it's you are not showing the what do we say the clear data or clean data. So in general, what we do, because we want our model good. Okay, we want our model which can perform better. So what we generally do, we take some pre-processing technique like which can filter out some of the noises from the image, like some filtering technique, or there are a lot of image processing technique. Just apply over that so that maybe some of the noises would be removed and your image would be more clear. And if your image is more clear, then your model will learn better. So it's like just one example. There are a lot of examples where this pre-processing is needed, and this totally depends on the data set or problem statement that you are solving. Maybe in the medical imaging, this is very required thing because most of the time you will be having a lot of noisy data, and then you have to do this because if you do not do, then everything will go wrong. So when we resize the medical data for people, there may be chance for okay. Yeah, this generally happens. So resizing is like if you can do your work without resizing, then that is very good. But if you are not like in like without resizing, if you're not able to train your model, then definitely you have to resize the image. And if you do the resizing, you'll be losing information. That is always there. But even if you're doing resizing, then you just use some interpolation method. So there are few like several interpolation methods which do this resizing smartly. So it tries to uh, take care of the like the important information from the image. So maybe in that way you can go. So just don't do simple resize. Don't apply simple resize. But instead, just apply some interpolation method so that you'll be not losing a lot of information. But still, if you do the resizing, you'll be losing some information. But again, if you're losing information, your model, you are going to train the model, and your model will, because you are showing that only to the model, then model has to do the tough job, but model will learn. Like if there is information loss in the image, then I have to work well because you are going to train your model. So your model will be having the tough job, but your model will take care of that. So somehow it will take care of that and it will learn that. But this totally depends on the problem statement that you are solving. So if your problem is very complex, then yes, then model will be also in trouble. So it's not like every problem you can solve. Some of the problems are already like it's like very difficult even for the deep learning also. Suppose you have some data, suppose you have some problem. Suppose your client is, maybe I should take some other, because most of your background is not this company, so you're working as a professor. So suppose you want to work on some research work, and but for that you do not have data, you do not have much amount of data. Like suppose you want to solve one problem, and you took some images, maybe 100 images, and then you just say to your student that please take these images and train one deep learning model. And that problem, let us assume that that problem is very complex problem. Then it's very difficult. Your model is not like magic box, like everything it will learn. A model will not, in that case, maybe your model will not learn, or maybe it will overfit it, or maybe, yeah. So actually, this totally depends on the problem statement that you are solving, how complex your problem is, and how much information you have related to that problem. So if you have a lot of information, information is samples or data. So if you have a lot of data, huge amount of data, then you can make the model which can solve the particular. The ML model gives different results on multiple levels. What all step could we take to ensure its robustness? Different results on multiple runs. Yes, even if you take the same model and you run multiple times, it will give you different results. That is also there. Actually, this is happening because your model is every time your model is taking random that value differently. So in general, what we do, we fix the seed point. Like if you're taking zero at the first time, then every time you should take zero only, like initial value, what your model is going to take. So if you take the seed point same, then I don't think that like after multiple runs, your values would be changed, your values would be different. But yes, if you're not taking that and if you're running, then even the same model will give you different results at different time. But if you take multiple models, then definitely that will give you like every model will give you different results. That is always there. So again, the question was ML model gives different results on multiple. What all step could you take to ensure it? No, actually, but whatever results you will be getting, there will be no much variation. There will be variation, maybe 1-2%, and that is fine. Suppose one is giving you 92%, one is giving you 90%. Like same model. If you run one time, then it maybe for first like you took one model and you just run for few epochs and you got some result, maybe result like n. And then again, you are using the same model and you are running for some other epochs, and then you got some results. So that result should be it would be like only n plus minus maybe 2 or 3. So there should not be much change. If you have if you are getting a lot of variation, suppose 20% performance variation, like one is giving you like same model is giving you one time 80% and next time 60%, then there's problem in the model. Then maybe your model is getting overfitted or underfitted. But if you have good model, then your model, even if you run multiple times, your result would be changed, but it will be not changed very marginally. Like it will just point plus minus 2 or 3, plus minus 2, like that. Or maybe it can vary up to 4%. 4% is also very high number. But in general, what I observe that it's like plus minus 2 or plus minus 3. Okay. So if there is no question, if any question, then please ask. Otherwise, maybe I'll. We have some time. Then you could ask question. We have some 5 to 10 minutes. So I assume that uh, most of you have like existed. Like it's like totally 1 2 hour is like very